video is all about the winner, shall we say, of which mill we're going to convert to CNC. And no surprise really, 70% of you, I will say mostly American, have opted or elected for me to convert the PM30MV, which is an absolute lovely machine. In Australia down here, that particular model is called the Optimum MH28V, and of course it's Optimum. Now this is the same machine, okay? There's only one difference between them, and that is the Australian Optimum version. When I say Australian, this actually is a German designed machine. The only difference between the PM and the Optimum is the Optimum has a 2-speed gearbox, okay, and the maximum RPM on this one is 2,500, and on the PM it is 3,000. So that's the only difference between them. All the measurements and that of travel is the same, I believe. And this one is belt drive driven. This one is gear driven. So this machine, yesterday I ordered it and paid for it. It's going to take about 2 weeks to get to me because I live in Tasmania. It's an island off the southern coast of Australia, still a state of Australia, but it's about, let me see, Hobart is about 500 kilometres, about 400 miles from Melbourne. So it's got to be loaded onto a truck, truck's got to go onto a ferry, of course it's overnight then into Tasmania, and then overnight drive then all the way down across the island to Hobart, and then I go and pick it up. So all that's going to take at least a week and a half, because you know, it's not an immediate thing. And the company that I bought this from is called Hare and Forbes, who is the main tooling distributor of Australia, actually. And as a result of me purchasing this from them, they have become a sponsor to the channel, which is another plus. So I'm just going to bring up some of the specs on this. Let me see what we got up here. Oh, it's a 3MT 3 Morse taper in the spindle here. It's let me see, the X travel, which I don't think I'm going to extend. It's going to be let me see, 430 millimeters, which is 17 inches, which is quite much travel in the X. I'm going to put two 4-inch machine vices on here, so that the travel in the X is fine. I don't think I'm going to extend that, but I will extend the travel of the Y. The Y is, see, 220, which is 8 3/4 inches. I'm probably going to take that out to 10 inches, which is 250 mil. millimeters, that is. So I'm going to extend it by, inch and a half, something like that, which is not difficult to do. I don't like, right, to extend the wide travel, I'm going to have to machine some out of the bed here, out of the base. Then I don't want to take too much out of it. I don't want it warping or anything like that. I still want to keep all the strength in this base. Incidentally, the weight of this is, actually I did have the weight on here, it's not on there now, I must have cut it off. Whoops, must have cut it off. It's about 240 kilos. 240 kilos. Now I should have worked this out before I started videoing, but we'll do it now live. So, I did do it. 528 pounds. Now you can tell a lot about how rigid a milling machine is just by its weight, and that's a good indicator, okay, to understand how rigid the whole machine is going to be. Sort of nearly 530 pounds in weight. That's a fairly damn rigid machine. So it's for the equivalent Sieg machine. This is probably 100 pounds heavier. Okay, so that will give you some indication of, okay, well, it's going to be a bit stiffer than what the Sieg would be. The equivalent Sieg machine to this is about $1,500 more. This machine's $3,000, and the Sieg is $4.5 grand. I just don't see the value. So that's another good reason. I think probably you guys have seen, the same thing as me, and this is why you've opted for this particular model, or in the American case, the PM30. And it is, the best all-rounder, best all-round choice. Anyway, so initially what I'm going to do is, when I get it here, is obviously I'm going to have to strip it and measure it all up and sort of design a kit for it, I suppose. When I say a kit, I will not be producing the kit. I will be producing the drawings, and they will be available on Patron at the end of the whole process. I shall probably be making about 10 to 12 individual videos on making every part of this, into CNC, and showing you every detail of what you're going to be in for, which is what I normally do. And at the end of the process, within a month after finishing it, the drawings will be available on Patron. However, I am unable to supply the CAD files. My agreement with Fusion doesn't extend me passing on files that I've created, just the videos. Okay, so what I'm going to be doing with this particular model, because I'm going to be mounting on here two 4-inch vices, machine vices, that is, the big heavy ones. It's a lot of weight to be sort of, you know, speeding up, slowing down, stopping, changing direction, you know, for stepper motors. Incidentally, they're not going to be stepper motors. I'm going to be using closed loop steppers for this, which seem to be all the craze now. You can run them a bit faster. You know, they've got a little bit more torque with them, and they're a little bit more controllable than what standard stepper motors are. You know, there's no fear with them losing steps. So that's what we're going to go with. Not going to be able to use NEMA 23s. They're just not powerful enough. Not even NEMA 24. We're going to go NEMA 34. I'm going to use 4.8 newtons for the X and the Y. I'm going to use a 9 Newton meter for the Z. I know a lot of the guys out there, they'll put a 12 Newton meter on, you know, on the Z. I'm going to be using dual race, all right, or double ball nut race 1605. Okay, ball races and screws for every axis, including the Z. And what I'm going to do there is, and I know it's a lot of weight for a 1605 to have on it, but I'm not sure what I'm going to actually do yet. I'm going to do one of two things. I'm either going to put a couple of gas struts, you know, on the underside of the head to assist in the, you know, the weight movement, or I do have an old multi-gym actually with weights and pulleys, and I'm thinking of running a series of weights over the back over a pulleys system to connect onto the head to, you know, distribute the weight then, or offset the weight of the head. I'm not sure which idea I'm going to use yet, but one of those two things I will be doing. That's why I can use a 1605 dual ball race and screw for the Z axis. And there's not much point in putting a 12 Newton meter you know, stepper on the end of a 1605 shaft, because it'll just twist the end off. You know, if you use you know, the full 12 Newton meters on because it's a 10 millimeter shaft drive, it's just going to twist it off. So there's not much point in doing it. Not much point in using one that powerful. So the 9 Newton meter will do the job absolutely fine. I dare say, with you know, the weight offset, I dare say you know, if I used you know, 4.8 Newton meter one, that would probably do it as well. But I'm going to the 9. I want to be sure of driving it without any problems, so that's why I'm going to 9. And of course I'm using closed loop steppers as well. You can run them a bit faster, you know, and they're a little bit more powerful as well. So you know, killing many birds with a single stone. I do intend to go all the way with this as well. I'm going to do the, you know, the main build and sort of get it all going, and eventually I want to put a power drawbar on here, and we'll see how it goes, and eventually possibly I wouldn't mind making a carousel for it to go fully auto change. Obviously I want to belt drive it as well, and at that point I should be changing the motor out and put in a 3.2 kilowatt high-speed spindle, actually a router spindle motor in there, and belting it up probably 4 to 1. That will give me 6,000 RPM then at the spindle. And why I'm going to 3.2 kilowatt is because the 2.2 kilowatts, the 80 millimeter diameter body, they're not bad. They probably would do it okay, but I want to be sure of having, you know, sort of decent torque, so I can use a, you know, sort of a face cutter of approximately, you know, 3-inch, something like that, and being sure of being able to drive it at about 1200 RPM, which means, you know, the motor will be doing, if I belt it 4 to 1, we'll be doing about 5,000 RPM, which will be fine. And the larger size spindle motor of 3.2 kilowatt, they are 100 millimeters in diameter body, as opposed to 80 millimeters for the 2.2. So the rotor is that much bigger diameter, equals more torque. So that's why I'm gonna go that way, but we're talking 18 months from now. I bought, like I say, I bought and paid for this yesterday, so you know, it's going to take a week and a half to get here, and it's probably going to take 6 months for me to do the build. Maybe a little less, but I'm saying about 6 months to do the entire build, because I've got to build an enclosure as well. I think I'll do that in 2 stages too. First stage, I'll just build a, you know, sort of a stand for it, and then actually do the conversion off that stand, because I shall be completely taking this apart into its individual sections and just, you know, sort of end up with just the base, you know, start off with the base and sort of, you know, build the y-axis, then build the x-axis, then build the y-axis, the z-axis, and then mount it back on, and then tram it all in. You know, retramming the column in and what have you. Fair bit of work, but I think we'll all enjoy it. So that's where we're at, and like I say, I intend to go all the way with this one, and I hope you come along for the journey. For those of you who have also been asking about the QueenAnt, it's right here next to me, or in front of me actually, and I have been sort of looking at it and stripping wire for it and getting stuff ready, and I'm starting filming actually tomorrow, and I may have a video up doing all the 240 mains voltage work first with that. I don't think I'm going to do a video of me programming the VFD, because I've done 2 of those already, and you know, I don't want to sort of go over stuff that I've already done, because it would be an identical video to something that I've already done. But you know, we're going to get stuck into that, and I want to get that finished over the next few weeks. We'll get that finished, and we'll get that up and running, and start doing a bit of work with that as well, because I want to use one of the CNC routers to machine some of the aluminium parts for this, and I'll probably use, you know, alternatively, because I've got 3 of them, you know, I want to see if I'm pretty sure the QueenAnt will cut aluminium all right. I want to see about the 6050 plus over there too, see if that will cut aluminium. It should be all right. And do a couple of videos with those as well. So there's an update for the channel, and we'll be starting to make videos on this, I think probably in about 2 weeks time. We'll get it in and make some sort of somewhere to, you know, work on it and run it and see how it performs, and then we'll strip it and see what we've got to do. So thank you for watching the video today, and if you like what I'm doing, please like and subscribe. And if you really like what I'm doing, it would help me out an awful lot to do a number of things: to pass the video on, to definitely like and subscribe, and if, like I say, you really like what I'm doing, it would be, you know, a really big help if you would consider becoming a patron to the channel, because it is the patrons behind the channel that enable me to do things like this and to keep going, because sometimes it gets pretty damn hard, you know, sort of being able to afford to make high-tech videos, because, you know, I don't get given any of these machines. You know, they don't mind sort of helping out with small things, but I have to purchase them, yeah, to be able to make videos. So there you go. So if you could consider becoming a patron, it would be a big help. So until the next video, probably going to be a QueenAnt. It's bye for now.